This is the video for Unit 2, Lesson 3, factoring trinomials. So the goal in this is going to be to factor trinomials that have an a value of 1 and to factor a trinomial with an a value greater than 1. So if you remember previously, we talked about factoring polynomials, and we talked about our first two things that we always look for, which is a GCF, which greatest common factor, or we also had grouping, and this was specifically we saw when we had 4 terms. We're not going to look at factoring trinomials, and trinomials you might remember from Math 2, where it's in the form of ax squared plus bx plus c. So we're going to look at what do we do when our a value is 1, so how do we go ahead and factor that, and what do we do when our a value is greater than 1. So that's kind of our focus we're going to be looking at today. So the first thing we're going to look at is what happens when our a value is equal to 1. We're going to kind of approach them all in a very similar way. We're going to see when a is greater than, or a is equal to 1, we don't have to really do as much. It's more when it's greater than 1, we have to do some grouping. So if I have x squared minus 4x plus 3, that's really kind of the same as saying there's like a little 1 in front almost. And what we're doing are factors of 1 times 3, or factors of 3, or that multiply to 3. And we're going to look at where they add up to that middle value, which in this case is negative 4. And so if you might remember from Math 2, you make a little bit of a table, and we're looking for two numbers that multiply to positive 3, but add to a negative 4. Few things we want to remember. If it multiplies to a positive, the signs are the same. In this case, it adds to a negative, so that means that they're both going to be negative numbers. So if I look at two numbers that multiply to give me 3, I have 1 times 3. But I want them to add to a negative. So negative 1 times negative 3 is a positive 3. And when I add negative 1 and negative 3, I get a negative 4. So that would be my factor pair. If a is equal to 1, I don't really have to do much else after that. So I don't have to do any other type of like grouping that we're going to see. Really all we're going to do here is I can say x minus 1, x minus 3. So those are my two factors I just found, 1 and 3. And this would be my factored answer, right? If I was to want to check it and I distributed this back out, which we wouldn't have to do that, we would actually end up back where we started. So the goal was to factor our trinomial into two binomials, which means two terms, and that's exactly what we did. So again, this is when a is equal to 1, we can do that. For question number 2, it's essentially the same thing, right? So again, I have an a value of 1, so I don't have to do a lot of extra stuff. I'm looking for factors of 1 times negative 5 that multiply to negative 5, but we'll add to a negative 4, that add up to that negative 4. And some students like to think of it like it makes a house, like this is the house, right? And they're adding up to that middle value. So if I look at this, the numbers multiply to a negative, so that means they're going to be different signs. And the larger number is going to have that negative. So if I was to list all my factors of 5, I would actually see that positive 1 times negative 5 gives me negative 5. And when I add them, I'm going to get that negative 4 that I want is for my middle value. So from there, all I have to do is I'm going to take my two factors that I found. Since my a value is equal to 1, I can just rewrite it as x plus 1, x minus 5. And if I was to distribute this back out, I would get that same trinomial, right? Because 1 times negative 5 is negative 5, and 1 plus negative 5 is negative 4. For the bottom two U tries, those are for you to try out. So again, a is equal to 1, which means that value in front of x squared is 1. And so you can do the same thing. For the second piece, well, what happens when our a value is greater than 1, right? So notice for these, a is greater than 1. So when a is greater than 1, we have to do something a little bit different. Just taking the two factors we find isn't going to give us our answer. So we're going to approach it the same way. I have 2 times 3, which is 6. I'm just doing again 2 times 3 and getting 6. So I'm looking for numbers that multiply to a positive 6, but add to a negative 5. Okay, so when we go ahead and list this, the numbers multiply to a positive, so they're going to be the same sign. But they're both going to be negative. So if I list my factors of 6, I could actually see I'm going to use negative 2 times negative 3. Because if I do negative 2 plus negative 3, I'll get my negative 5. Now what happens is I can't just simply say x minus 2, x minus 3, because if I multiply this back out, I'm not going to get 2x squared. I'm going to get just an x squared. So we end up having to do something different when a is greater than 1. So what we're going to do is we're going to do something called grouping. So very similar to what we did in the previous section. So what we end up doing is I'm first going to take my original trinomial, and I'm going to split this middle term and rewrite it with the two factors I just found. So in place of negative 5x, I still have my first term the same. I still have my last term the same. But in place of that middle term, I'm going to write negative 2x minus 3x, right? So really what we just did is we took that negative 5x and rewrote it. And if I was to combine those like terms, I would still get negative 5x, right? So all I did was just rewrite that polynomial or that trinomial. Now we're going to do just what we did in the last section. I can now group my first two and my last two terms together. So in the first pair, I can pull out a 2x. So I'm going to get here 2x, and then inside it, again, I have two terms. I need two terms on the inside. I'm going to get x minus 1, so this doesn't go completely away. In the second pair, it starts with a negative, so I got to pull out a negative, and they both have a 3 that goes in there. And again, if I start with two terms, I have to end with two terms. So I'm left with x minus 1. I know I'm doing it correctly because my parentheses match. And so I have x minus 1 and then 2x minus 3. Now, if you wrote your factors the other way around, so let's say instead of 2x minus 3x, you wrote negative 3x and negative 2x, you would still get the same answer, just when you're finished, you might have the 2x minus 3 as your first parenthesis, but it's the same thing. And that would be it. For the second one, we're going to do the same thing. And then I just want to kind of remind us some of the steps. We do want to make sure we're still checking for our GCF. So do I have a GCF? I don't have a GCF, so I'm not going to do that. It's not 4 terms, so I'm not going to do my regular grouping. So I'm going to go ahead and cross that out. But it is a trinomial. So that's why we're going to go ahead and do our next step. I can see that, A does not, does A equal 1? No, it doesn't. It's actually a 3. So when we multiply, we're going to do the same thing. So 3 times 24 is going to give us 72. And we're going to look for factors of 72 that add to 22. So when we go ahead and list all of our factors of 72 that add to 22, and we kind of list these all out, we're actually going to get our answer to be 18 and 4. And so now, once we get our factors, probably the most challenging step is taking this and rewriting it. So instead of having 3x squared plus 22x plus 24, we're going to rewrite our middle step, which tends to be the trickiest because it's like you're adding something that's not there already. So we're going to rewrite our middle term as 3x squared plus 18x plus 4x, and then the last term still stays the same. I still have that plus 24. So the last term for each of these and the first term stayed the same. We're then going to group like we did before. So the first pair, I'm going to pull out a 3x. And I get 3x, and I get x plus 6. My second pair, I'm going to pull out a positive 4. I get x plus 6. I'm doing it correctly because I can see my parentheses match. So x plus 6 is my first pair, and then 3x plus 4 I'm writing as my second pair. And you could have it the other way around too, because multiplication is commutative. For the last example, it's the same thing. So again, we first always check our GCF. I don't have one. We aren't going to group with 4 terms, and the a value is not 1. So we're going to do the same thing. So 6 times negative 14 would give us negative 84. Factors of negative 84 that add to negative 17. And then our 2 factors are going to be 4 and negative 21. And then now we're going to go ahead and group this out. So I have here my original. I'm going to split it. And then just go ahead and group it out. So the first pair, I could pull out a 2x and get 3x plus 2. My second pair, again, it starts with a negative, so negative 7. And then I get 3x plus 2. We know we're doing it correctly because the parentheses match. And then we're going to go ahead and write what matches. And then the leftover is 2x minus 7. And that would be our final answer. The U-tries, obviously, you need to complete. And that's it. So if you have any questions, feel free to ask questions in class, sign up for T-Bolt time, or go to the center.